Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 8th grade topic, multiplying exponents. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see here today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video will have 2 parts, so leave a like, smash subscribe, and let's get started. Before we jump into multiplying our exponents, let's have a very quick recap on what exponents look like. Now, you may be familiar with the basic form, which is a number raised to another number. Now, this bottom number, we call that the base, and you see it's much larger than this top number. This top number, we call that the exponent. So when we're talking about exponents, it's really just this mathematical expression where you have a base, which is a bigger, not necessarily like larger number as far as numeric value, but physically, size-wise, it's a bigger number than this smaller number. Once again, is not about the numeric value, but just how small it is compared to this bigger base. This is your exponent, that is your base. Now, this is the most basic form of your exponent that you may have seen plenty of times by now. However, our exponents have a lot of different forms they can take. Now, this is your number raised to another number. However, exponents don't have to just be numbers. You can have, let's say, an exponent with a variable up here. So you still see you have your base, but your exponent is not exactly a number per se. It could be any number. So it's not a fixed number. It could be any number. This is still what we refer to as exponent up here. This is still your exponent. Also, you can have a different base. You don't have to have a numeric base. You can have a variable in your base, and you can have a number in your exponent. This is still your exponent. The only thing that's different is your base is now not a fixed number, but a variable. This is still going to be your base. So you see it still has the same makeup. And you can take it a step further. You can have a variable with a variable, just like that. So a variable base and a variable exponent. So our exponents can have a lot of different forms, whether you have number raised to a number, number raised to a variable, variable raised to a number, or even variable raised to a variable. You can even have an exponent that looks like this, something raised to a mathematical expression. So regardless of what your base is, your exponent is not a single digit or even a single variable. You can have a whole expression be your exponent. This is perfectly fine. So don't get pigeonholed and think that your exponent just has to be a number or even just has to be a variable. Exponents can be a lot of different things, but your exponent is still going to look relatively the same way, where it's going to be raised to the top right and it's going to be smaller than your base number. This right here, just to exaggerate it, this base is a bigger number in size than this entire expression. This is how your exponent is going to look. So we had our quick recap. Now let's talk about how it works. How do we actually go about multiplying our exponents? Now, we really should call it adding exponents because that's how we technically do it. But when we talk about multiplying exponents, we're really talking about multiplying the expression. So let's say you have this 2 cubed. You're going to be multiplying an expression, this entire expression, by this entire expression. This is what we're referring to when we say we're multiplying our exponents. Technically, we're multiplying these 2 expressions. However, we only move on to the next step of this if and only if your bases are the same. If your bases are not the same, this is as far as you go. You can't go any further. However, if your bases are the same, you can move on to that next step. Now, what is that next step? So let's say you have 2 cubed times 2 to the first power. In order to multiply these expressions, you check to see if they have same bases. They do, so let's move on to the next step, which requires us to simply add across the exponents, add across the tops. We don't have to do anything more complicated than that. We're simply adding. So you can even write like a very faint plus there to remind you that you're going to be adding the exponents. So you keep the base the same. So you see this is a 2, this is a 2, this is going to be a 2 as well. And you add across the top. So 3 plus 1 gives us a 4. That's all we have to do. So once again, multiplying our exponents means we're going to multiply the expressions. And we only move on to that next step if we have like bases. So what are we going to do here? Are we going to add across the tops? No, we're not. We see they don't have like bases. Remember, we have like bases only because we have to write that same base over here. We don't know if we're going to have a 2 or a 3. So that should tell you that we can't multiply these expressions. 2 is not 3. Since you can't simplify this further, this is all you're going to get. How about this one? Remember what we said. You can only add across the tops if they have like bases. Do these have like bases? No. So you will be tempted to say you can't add across the tops. However, there is a little caveat for this type of equation here. Now, since I called it an equation, I technically should write an equal sign here. But this is a special type of equation. Now, I'm not going to break the rules and contradict what I just said. We can only add across the tops if they have like bases. But in this case, we can make them have like bases. So if one of your bases can be transformed into the other base, you can technically add across the tops. However, you have to make sure they're in like base form first before you do so. So you can't just simply add across the tops now because the bases are still different. First, transform one into the other, and then you can have your adding across the top. But now you may be asking, well, how do we transform one of these into the other? We have something in common here, right? 27 has 3 as a factor, but is not just a factor. You can technically reduce 27 down into a 3. So 27 cubed, what does that even mean? Well, that means, I'm gonna just bring down this 3 squared just to kind of bring it along with us. But that means we have 27 times 27 times 27. That's what this 27 cubed means. Let's look at this 27. Can we write 27 in exponent form? Well, what times itself multiple times gives us 27? That's going to be 3, right? You know that if you multiply 3 times 3, you get 9. And if you then multiply that 9 times 3, you get 27, right? So that means you have 3 times 3 times 3 will give you 27. 3 times 3 times 3 is going to be what? Well, like bases, right? They have an exponent of 1 here. So that means you're going to have same base. 3 times 3 times 3 gives us a 3 base. Add across the tops. Cubed. So this 27 can be rewritten as 3 cubed. And if this 27 can be written as 3 cubed, both of these 27s can also be written as 3 cubed. So let's rewrite this as 3 cubed. So we have 3 squared times 3 cubed times 3 cubed times 3 cubed. Well, can we do something about this 3 cubed times 3 cubed times 3 cubed? Yes. And actually, we can probably just drop these parentheses because what do we have here? We have a 3 squared times a 3 cubed times a 3 cubed times a 3 cubed. All of these are the same base. So if all of these are the same base, we have essentially done our first step. We have made them into the same bases. Now we can move on to that next step of adding across the top. So now we have this 3 squared times 3 cubed times 3 cubed times 3 cubed. That means our final answer is going to be 3 for our base, and we're going to add across the tops. So what's 3 plus 3 plus 3? 9 plus 2 gives us what? 11. So this is 3 to the 11th power is our final answer. So you can technically just write 3 to the 11th power. Now there's a shorter way of doing this, but I'm gonna cover that in another video. For right now, I just wanted to kind of get back to the basics of what we know about exponents in order to show you how it's easy to multiply our exponents, or technically multiply our expressions which causes us to add our exponents. So I hope you are following today's examples, and I hope you see it's pretty simple to multiply your exponents. As long as you have those like bases, you can simply add across the top and you're done. But if you had any questions about what you saw today or even your own homework, you can always put it in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.